All right, you guys. Hopefully, you guys are healthy and doing well. Today is the second day of statistics, which are the only new things that you guys will be having the rest of this year. Yesterday, Mr. Johnson did a lesson on frequency tables or two-way frequency tables, and today I'm going to do the video on two-way relative frequency tables. So let's take care of some prior knowledge. So first off, one thing that you need to remember is how to turn a decimal into a percent. So for example, if we have 0.2, and we'll add another 0 to make it easier to understand. What we are doing is to turn it into a percent. Normally we would multiply by 100, and 0.20 times 100 would give you the 20. But if we want to do it a faster way, all we do is we take the decimal, move it to the right twice, and then we would end up with 20%. So hopefully that's something you remember, because we're going to need that for this, actually for the first two problems. So let's go ahead and start. A group of 40 people who like to cook and 40 people who don't like to cook were asked if they like to taste unusual foods. The two-way frequency table shows the results. So yesterday, Mr. Johnson showed you how to fill this in so you can see all the information there. And so now let's go ahead and take a look at the question using this frequency table. So the question asks, what percent of people who like to cook don't like to taste unusual food? So we're looking at the people who like to cook. So we're going to be using these numbers here. So from what you can see there, out of the 40 people, there are 28 who like to taste unusual food, and then there are 12 who don't like to taste unusual food. So I always found it easier to write my fraction in words first, and then substituting in the numbers. So it says, what percent of people who like to cook? So of the people who like to cook. So this becomes our denominator. And then continuing, don't like to taste unusual food. So that becomes our numerator. So these are the ones that don't like to taste unusual food. So now let's turn that into numbers. So the people who like to cook, so these are the people, there are 40 people who like to cook. So that is our denominator. The people who, of those 40, the ones that don't like to taste unusual food, there are 12 of those. So that is our numerator. Now, if you wanted to, yes, you could go ahead and simplify that, but we don't need to. So all we need to do is, in your calculator, hit 12 divided by 40, and you would end up with 0.3. Again, remember what they are asking us to do. They want us to turn this into a percent. So I'm going to move that decimal to the right 2 times. And then I end up with my percentage of 30%. So 30% of the people who like to cook don't like to taste unusual food. So that takes care of number 1. So basically that's the process that you will be using throughout this whole lesson here and all these problems here. So let's take a look at the second one. The two-way frequency table shows the result from a recent survey about whether people prefer to watch a movie that is a comedy or a drama. So again, Mr. Johnson showed you how to fill this in. They actually did the work for you, so all that's been taken care of. And now let's take a look at the question. It says, based on the table shown, fill in the relative frequencies by column. So column meaning they want us to take a look at this straight up and down. So we'll be thinking, look at this information straight up and down. So we're going to have two columns. We're going to have men, and then we're also going to have women. So we're going to do the work in two separate places, and we're going to figure out all these frequencies. So we'll start off with the men. So then what percentage of men who were asked, who were surveyed, like comedies, and then what percent of men who were asked again, like drama. So let's take a look at those. So again, I found it easiest to write things in words first. And actually my men should be in blue, so sorry about that. I will fix that color for you. So we're going to first find the percent of the men so our total men, and which one of them or how much of them like comedies. And then, so how many men were surveyed? There were actually 40. Out of those 40 men, how many said that they like comedies? There were 28. So again, let's just do the math by dividing. You do not need to simplify. So 28 divided by 40 would give you 0.7. If we were to turn that into a percent, we move the decimal to the right twice, and so we end up with 70% of the men who were surveyed like comedies. So now let's find the percent of those men again. So we're going to write again our fraction. So total men. And this time we want to know what percent like dramas. We already know that they surveyed 40 men. And this time, how many of them like dramas? So there were 12 out of those 40 men. So we will put a 12 there. Again, on your calculator, 12 divided by 40 comes out to 0.3. And if I want to turn that into a percent, that would give me 30%. And again, a real quick way to check to see if I have that right, that 70% and the 30% should be all the men that were surveyed, so that would give you 100%. 70 plus 30, it gives you 100%. So I know I have all the men accounted for. So there's the men. So 70%, let's fill in our table now. And again, this is supposed to be in blue. So 70% of the men like comedies, and 30% of the men like drama. So let's take a look at the women now. So we will make the women in red. And we're going to take a look at the numbers that are circled in red. So again, they asked 40 women. And we will do our fractions again. So this time it's going to be the total women. And we want to know again how many or what percent of them like comedy. So let's take a look at the raw numbers, the actual numbers first. So we know again that they asked 40 women total. Out of those 40 women, 18 like comedies. So out of the 40 women total, 18 of them like comedies. On your calculator, 18 divided by 40, and you end up with the 0.45. Again, turning it into a percent, move the decimal twice, and so we get 45%. And already there are some of you that have already figured out that if there's 45% of the women who like comedy, you can pretty much, using common sense, there has to be 55% of the women who like dramas. So you have an idea as to what the number should be, but let's go ahead and verify. So we're going to take a look again, the total women. And above is the drama. It is still the same amount of women that were asked, 40. And this time we need to find out how many of them like dramas. So this time we can see that there were 22 women who like dramas of the 40. So there's your 22. Using your calculator again, you end up with 0.55. And again, some of you are going like, I knew it. And so yes, there were 55% of the women who like dramas. And so if we fill in our chart here, 45% of the women like comedies and 55% of the women like drama. And so there is number 2. Let's take a look at the last one. Again, the little prior knowledge that you're going to need to remember. This time we're going to go in the other direction. We need to remember how to turn. So turning a percent into a decimal. And let's give you an example. So let's say 40%. So I am going to drop the percent. Your decimal is actually there, and I'm going to go to the left this time, 2 places, which means I can end up with 0.4 or 0.40 if you would like. That's okay to do. All right, so here we go. A two-way relative frequency table shows the results of a survey about whether or not children of different ages could blow bubbles with bubblegum. A total of 40 6-year-olds and 25 10-year-olds were asked if they could blow a bubble with their gum. And as I look at the table here, I see that everything is in percentages. So what I'm going to suggest you do is that let's turn those percentages into actual kids, actual number of kids. And so let's do this work down here at the bottom because we're going to need some room here. And so I'm going to go ahead and create me some space here. Make a line there. Let's use green for the 6-year-olds. So I am told from the actual problem that there are 40 6-year-olds. All right, so there are 40 6-year-olds. So I need to write that down here to make my life easier. So there are 40 6-year-olds. So let's find out how many actual kids can blow a bubble. Out of those 40, I know that there are 20% that can blow a bubble. 20%. So now I need to turn that 20% into a decimal. So if I move the decimal over to the right, I end up with 0.2, or if you like, 0.20. So let's do the math. So on your calculator, 40 times 0.2, and you end up with 8 kids, 8 actual 6-year-olds that can blow a bubble. So that I can remember that right now, I'm going to go ahead and come up here, and I'm going to put that this is actually 8 of the 6-year-olds that can actually blow a bubble. All right, of these 6-year-olds, how many can't blow a bubble? Again, there were 40 of them. And out of those 40, 80% could not blow a bubble. So again, taking the 80%, moving the decimal to the left twice, I end up with 0.8. And on your calculator, if you multiply 40 times 0.8, you end up with 32 actual 6-year-olds that cannot blow a bubble. So I'm going to go ahead and write that number here. And a quick way to double check, 8 kids who can, 32 kids who can't. That's the 40 6-year-olds that were a part of this. Was it a survey? Yeah, I think it was a survey. All right, so let's take a look at the 10-year-olds. There are, I believe, 25 10-year-olds. Yep, 25 10-year-olds. So let's do the work for them down here. It's a lot easier to take care of the work first, and then you can just use your information to figure out what you need. So there were 25 10-year-olds. And we're going to do the same thing. We're going to figure out how many of them can blow a bubble. So first off, can blow a bubble. So there were 25 of them. Out of those 25, I am told that 72% can blow a bubble. So again, 72%, take the decimal, move it to the left twice, we end up with 0.72. Calculator, 25 times 0.72, I get 18 kids. So 18 out of the 25 can blow a bubble. Now again, some of you guys have figured this out, that I should get 7 of them who can't. But again, we will do the math. So how many of these 10-year-olds can't blow a bubble? So 25 10-year-olds. This time, how many of those kids are there? What's the percent? 28%. So 28%, or 0.28. Calculator, 25 times 0.28, and I end up with 7 kids, or 7 of the 10-year-olds that can't blow a bubble. So I'm going to put that up there. And again, I can double check the 18 that can blow a bubble, the 7 that can't blow a bubble. Add those together and you get the 25 10-year-olds. All right, so I have all my raw scores there. So now, a lot of work, I know, I understand that, but let's get this done. Select the statement that correctly describes the results of the survey. It says to find the total number of children that can blow a bubble, you add the 20 plus the 32. So 20 plus 32 so far, it looks like they are confusing some things. So first off, the total number of children that can blow a bubble. Of the 6-year-olds, there are 8 students that actually can blow a bubble. And there are 18 of the 10-year-olds that can blow a bubble. And if I were to add those two up together, I would end up with 26 kids. So now they're adding 20 plus 32, so it looks like they mixed up some percentages and the raw numbers, the actual numbers. So nope, that cannot be the answer. Let's take a look at the next bubble. There are 60 more 6-year-olds who could not blow a bubble than could blow a bubble. All right, so let's take a look at the 6-year-olds. The ones that cannot blow a bubble, there are actually 32 kids. And then the ones that can blow a bubble, there are 8 of them. So if I subtracted those, is there really 60 more of the 6-year-olds who could not blow one than ones that can blow a bubble? Nope, that doesn't seem to work out real well. So nope, cannot be that one. Next bubble. There are more 6-year-olds who could blow a bubble than 10-year-olds who could not. So let's take a look at the 6-year-olds who could blow a bubble. So there are 8 6-year-olds who can blow a bubble. So these are the 8 that can blow a bubble. So I'll make a note of that just so I don't forget which ones these are. These are the 6-year-olds. And then it says there are more 6-year-olds who could blow a bubble than 10-year-olds who could not. All right, so let's take a look at the 10-year-olds who cannot. The 10-year-olds that cannot are 7. You can see that right there. So there are 7 10-year-olds. And looks like I got confused there. Who cannot. So there were 8 6-year-olds who can and 7 10-year-olds who can't. So are there more 6-year-olds who could blow a bubble than 10-year-olds who could not? Yep, 8, 7, 8 is bigger. So yes, this one is true. The last one, of those that could blow a bubble, there were twice as many 10-year-olds as 6-year-olds. So the 10-year-olds who can blow a bubble, there are 18 of them. So 18 of the 10-year-olds can. And there are 8 of the 6-year-olds who can. Technical difficulties, sorry about that. So 18 of the 10-year-olds can blow a bubble. 6 or 8 of the 6-year-olds can blow a bubble. If I go twice 8, that's 16. So no, it's not twice as many. It's actually more than that. So that would be a false statement. So you only should have done or bubbled in the third one. All right, you guys, do not forget that your teachers are holding tutorial sessions. Make sure that you either join in on the Google Meets or Google Hangout, or that you email your teacher during the hours, so in case you have questions. All right, don't forget that the answers are also being provided for you for the rest of them. So if you want to do that, again, hopefully you are safe and that you are doing well. All right, thank you.